All right. Well, thank you everyone for joining us today for this SwissCAM Made Easy webinar. My name is Joy Mooney. I am part of the customer success team here at NexGen. And before I pass things off to Eric, just want to remind you that we are recording the session today and a copy will be sent to you after the fact. Also, we will have a Q&A session time at the end of the presentation, but if there's anything that comes up while Bill is talking or Eric, feel free to drop those questions in the chat at the bottom of your screen. So with that, take it away, Eric.
All right, thanks, Joy. I just wish a hearty good morning to everyone out there. We're excited to go over SwissCAM Made Easy. I'm the COO at NexGenCAM and manage our technical staff. And Phil Jennings is also on here as one of our senior CAM specialists. And he has been using PartMaker for a long time, is definitely an expert on this product and on Swiss machining in general. So we're excited to dig into this topic. For the agenda, we have first, we're going to go into how we can improve results. And a lot of folks want to get into this part of the market. When you think about getting a Swiss machine, it has so many degrees of freedom, so many different axes that are at play. It can be a very powerful tool. It can also be profitable for companies to get into this higher end of the market. And so we want to talk about how you can do that and how you can use the CAM software to improve that. And then we want to talk about what our solution, what it's really good at. It has a proven ease of use. It's a purpose-built tool specifically for Swiss. It's not a tool that was originally built for regular milling and turning and then turned into a Swiss tool, but the other way around, that it's really focused into this high end of the market. We're going to talk then about synchronization and machine simulation, so how to get all the parts of this machine working properly and to give you peace of mind. Then we're going to talk about the advanced capabilities. There are some things that you can do. Definitely you can do hand programming at the machine. You can certainly piece together bits of programs from in other CAM softwares. But when it gets to some of these really difficult things, you really want something to do all the math for you. We're going to go through those. We're going to hit a brief success story, which is very representative of the results you can get with this solution. Then we're going to talk about everything that's included because Autodesk puts together a package. So when you get the Swiss CAM package, you're getting multiple different capabilities. And in fact, a lot of our customers now are using multiple tools out of this solution. I'm very happy with it. Lastly, we'll end on just IMTS and going over what we've got going on next week. If you aren't aware, IMTS is a big manufacturing show in Chicago. It starts on Monday, September 12th. It runs all of next week. So what we're really talking about here is getting into high precision programming, and it's not just for the Swiss machines, but also for the mill turn type machines. And what we're talking about is easy programming. So we tend to think of how do we take one operation or one thing that needs to be done and make it easy to put all of it together into one crescendo. I often think of it as an orchestra of all of these things coming together at once, all these different parts of the machine. Other folks would say 5-axis machining is kind of like a ballerina, cutting one part and cutting the ice. And this is more like a hockey team where it's a whole bunch of different things cutting the ice and cutting the chips off the machines. So when we do this well, we're reducing cycle times. Another key aspect is that the posts are customizable. We know a lot of people get very specific in this industry as to what they want and what they want to achieve. So these are open-ended posts that can be changed. And then also full simulation. In fact, most of our customers are using the simple simulation because they get good at understanding how the machine is running, and they rarely use the full simulation. But they do tend to use a lot of the shorter and simplified simulation, and we're going to go through all of that today. So digging into the next slide here, this is the place where we kind of take that purpose-built idea, and we've got a patented process table. This is the process table in PartMaker. We're going to be going back to it over and over again. It's really nice because in section A, you can drag and drop, you can put things in there, and this is kind of coordinating the whole machine together. You can have, what are the processes I want to end on that feature or on that process, and what do I want it to start on the next one. So this is really nice place to work. This is where we take Swiss and we make it a lot easier. Over in panel B, you can see where are we having it work in the machine. and what are the handoff points. And so this is great because visually you can see, you can move things around, and you can understand if things are synced, and it's just visually great to see it. If you go down to C, this is where you can see the cycle time. So what is happening in the total cycle time, and you can dial this in a lot more than we are today. If you want to put in all your specific speeds and feeds and the different information that you want, you can dial this in so that you're getting great information. And that can be helpful if you're quoting jobs or if you're putting together something and you want to get a quick understanding of what's our cycle time going to be in the machine. If you have all your machines configured, this is where it gets easier to use. The other thing about the process table is it helps you to start thinking about just programming in a different way. I know we talk to a lot of people that are doing manual programming, and they spend a lot of time thinking about the connection points. How am I going to get it to do this and then do this? And what's the order that it's going to be in? Because I can't go back and change and move things around when I'm doing a manual programming setup. This is a lot different because what we're saying here is to do it instead. Think about what's the best way to run that machine. What's the best feature to put on that part to make it run the best and have the best cycle time. So what we advise you to do is just get all the toolpaths into the process table, and then we can work things around. We can move them around. We can put things in different areas. We can test different scenarios, and that's the way that you can really ramp up your programming time. It's not unlike us to have folks that are spending eight hours, maybe a couple of days on programs. When they get good at this, they can do the same programs in a couple of hours or sometimes even 30 minutes if they're doing similar parts. The G-code optimization is also key. One of the things that comes with PartMaker is a multi-channel editor. We can do up to 3 channels. And so you can look at your code side by side, and you can really troubleshoot what's happening a little bit better than just doing it as a TXT file or some of the regular tools that people are using. It's nice. Another thing that we're a Simco dealer, and we sell the Simco editor. It's another tool that a lot of folks use to work on these machines. And we've got some great content on our YouTube channel. If you haven't subscribed to our YouTube channel, it's a great place to go and see more of what we can do. So digging into this, just looking at the visual synchronization. So how do we visually pull all of this together into one setup so everybody can see what's happening? And this is great. This is, the process table is going to show you that. So you don't need to see it as much as you would think when you've got the process table, making it easy, but it's also good to have this. Then you think about the simulation and posting code. We just have a tremendous amount of post-processors and past experience. PartMaker has been doing this for 20 years. And it's great to have all of this at your fingertips, knowing that you can run a lot of the machines in your shop. Okay, here are some of the tedious tasks. So if we just look at broaching, we look at like thread whirling, pinch turning, which I don't have necessarily in this slide. These are things that if you're going to do manually, it's just going to take a lot of time, and we can speed these up. We've got a number of the different broaching techniques that are available. If you look at thread whirling, thread milling, there's a lot of things that we've got in here that we can help you to do these types of tedious tasks really quickly. Then I think of complex tasks, like working in the B-axis, doing puller cylindrical, laser machining is another thing that we added into the product a few years ago. And all of these are just very complex. I wouldn't wish it on you to do this outside of a purpose-built program that can help you to do it well. And we're going to show you some of this today and hopefully make it a little bit easier to see. So at this point, I'm going to hand over to Phil Jettings. He's going to do a demonstration on this part we're showing in the lower right-hand corner. It's a new part he had just put together for this webinar. And he will take, roughly 30 to 40 minutes to go through all the capabilities. And at the end of the presentation, I'll jump back in with some success stories, go over what's in the whole product and the services we have to help you. So Phil, with no further ado, are you ready to go?
Sure am. Let me go ahead and share my screen. And just let me know when you can see the screen, please.
It looks great, Phil.
Okay, fantastic. So today's demo is going to include working with solid models. That seems to be the preferred method anymore. So I thought I'd just put together a solid model here, typical for Swiss machining. We've got some turning, milling, some 5-axis or B-axis work here, ID work, OD work. So the first thing you're going to need to do is to import the solid model, and we have a lot of import capability. On the wireframe side, we can import the DXF, we can import old CAD-L or CAD key files, the DWG drawings from any AutoCAD system. On the solid end, we do the neutral file languages of X_T and X_B. We can also read in native SolidWorks part files and SolidWorks configuration files, Autodesk Inventor files, STL models, ProE files, and step files. And the step file can also be used to import IGES files. So the step function does multiple import strategies for us. We just imported a solid model, an X_T file, and that will be listed in your Job Explorer here under the models. Next, we're going to set the origin. Now, this is part origin, but more importantly, it is also the machine origin. We're actually setting the part to the center of the guide bushing on the main spindle at XYZ0. That's simply done by using our edit part coordinate system. You just set a part origin, and then you pick a method for selecting off the solid model itself to set the origin. In this case, arc circle center will work. I've got arcs on the face. I select the arc. It highlights it. When I go to set the value, it places the origin where it belongs in the center of the part. Now, once you've done that, that's it for setting origins. All the other work that you need to do on this part will be done through our predefined construction planes. We have two patented processes for Part Maker. One of them is our setup dialog box, which is found in the upper left corner here. In the setup dialog box here, you'll tell the system where you're working, either on the main spindle or the sub spindle. You'll have a settings button here so you can set up some basic simulation. If you're using an extended nose collet on the sub spindle, we can place that extended nose collet on the sub spindle in simulation, so you'll see that. And we also use the value here, there's a little asterisk, and that's telling the post processor there is an extended nose collet, so that when we go to pick the part off, we've got to make sure we're adding that extra length in so that we pick off in the right spot. So that's taken care of for you. You won't have to add or subtract total stroke length for pickoff. Part Maker does that for you. Okay. Next, we have the stock profile. Right now, I'm in a main spindle turning window. We have the length of the part, the diameter of the stock, how much stock I'm going to remove on the face. Again, what we're doing here is we're calculating the entire stock profile being used to create the part. That way we can guarantee that each part will come out the exact same. So if you're facing, we need to know how much you're taking off the front so we can calculate that for the next part. The guide bushing length is the support length on the guide bushing. I just have a 1-inch guide bushing in here. This can be anywhere from like 625 to 1.5 inches, 2 inches, depending on what kind of guide bushing you buy. We also have the ability to take care of specialty guide bushings, JBS bushings, magic guide bushings. We can actually prompt the user to input that information so that we can make sure that we are, again, moving the bar stock correctly. Next is the predefined construction planes. I'll just click on the new button here so you can see this. So when you're working on the part, you will not create a construction plane. You will merely select from a predefined list. So a turning window, of course, is going to take care of all your turning, your grooving, your roughing, single point threading, thread whirling, that kind of thing. The XY plane is for working on the face of the part. If your machine comes with a Y slide, most Swiss machines don't, but if you do, you have the capability of using an XY plane. If you do not have a Y slide, then you will use a mill and polar plane. And again, since these planes are all predefined, your XYZ vectors are going to be correct for either the main or the sub spindle. Part Maker takes care of that for you. So we do have a few specialty planes. One of them is our milled polygon plane here that allows me just to create flats or hexes across the face of the part on the diameter here. We also have a mill cylinder plane for wrapping geometry, and I'm actually going to use that plane to engrave the company name and the process. And we also have true 5-axis capability. We can do simultaneous 5-axis, or we can do 3+2 positioning. And we've just added laser capability to the software as well. So if you're buying one of the newer Swiss machines that come with laser capability, we can program that right through the software as well. So with these predefined construction planes, all you need to do is determine where you're working on the part, what your strategy is, and then select the appropriate plane for that. So this one right here we're not using. I'll just go ahead and delete it. So I'm starting in a main spindle turning window. I've got my stock set, apply and close. Then what I can do is I can take the 3D model and project 2D geometry from that model. Okay. The reason I like to do this is if there are certain features on the model that I want to update. For instance, if we look at this, excuse me, if we look at this groove here, there's no edge break on that groove there. Well, I can project it into the 2D window, jump over to the CAD side, and just quickly add my chamfer. And I've updated the model simply by taking the 2D geometry and manipulating it. Very easy to do this. From there, once I've got my stock profile set, got my part all set up, then what I'm going to do is I'm going to load a tool library. And you can see in here all the tools that I'm using. And I'm also going to load what we call a cycles library. And what cycles do are basically multiple tool operations within a single group, so I don't have to create separate tool path strategies. In this case here, there's an 078 drilled hole that's on the 5-axis plane. I'm spotting with a flat end mill so I can create a flat. And from there, I can have the drill work from the flat instead of trying to drill on an angle. So it's a simple matter of just telling the system what I'm trying to do. If it's a tap cycle, I can create a spot, drill, and tap all in the same cycle. I can get the feature completed in one cycle. And then these cycles are saved off to be used in the future. So you can build your hole making database and then just keep using it over again when you need the profiles. From there, we start the programming, and our programming is done through our profile groups, which are tool paths. So the first program I'm going to make is a facing operation. So what you'll do is you'll just click on a new profile group. We do have 2 turning strategies available. The contouring strategy is what you're going to use 99% in a Swiss machine, which is either roughing and finishing or roughing or finishing. It's a 2-path strategy. But with the new modern machines coming out, you'll see larger diameters like a GT42, 42 millimeter bore. If you're turning down a piece of, say, stainless from 42 millimeters to 6, you're certainly not going to do that in one rough pass. So we have a turning strategy that allows for multiple rough passes. So when you need simple operations, you'll just be contouring. If you need a more complex operation with multiple passes, we just flip it over to turning. Once we're contouring the tool location, I'm facing the part. The system wants to know where I'm working with the tool, so I'll put the tool on the face, select the tool, whichever one I want to use, and then from there, when I close out this process, the facing operation is automated. We have established the Z0 on the model. So here's our axis of origin. Here's our stock profile. So we know that we have enough material to complete the part. In the 3D window, I can always show the shadow stock around the part. And also in the 3D window, I have the capability of showing stock motion, a sectional guide bushing, and then stepping through the tool path if I need to do that. Okay. So the main face operation, we set it up. it automatically creates the face operation. I can verify that operation in the 2D window. Or, like I said, in the 3D window, I can show the part inside the guide bushing and the motion of the part and the tool. From there, I created a couple of turns. Again, the idea with Swiss is always to remember the length of your guide bushing support. You've always got to work within that little envelope there. So this part right here, I split it up into 2 turnings because the part was longer than my guide bushing length. Now here is the original tool path, and then I got the revision in saying we want to put a chamfer on the edge. So I can merely take the tool path and modify it, and just step it back, and then add the chamfer into the profile. And the chaining function is just like any other chaining function from any other software. Be nothing you have to worry about here. And then from this position here, again, modifying, I can just decide to go to my ZX vector and tell the system I want to go to the stock profile. And the stock profile is 1.25. So I just type in my X value, 1.25, and I'm adding to the dimension. If I need to, I can always break the edge of the bar here. Again, we would just undo this. And in this case, we're going to use some motion to do a bar edge break, so we don't have to worry about a burr on the edge of the bar. So the first X vector is going to be 10th thou below. That'll be 1.24. Then I want incremental motion for Z, and the at symbol allows that. So I'm just going to go at 0.01 and put my edge break at 1.25. You can see that I'm breaking the edge, and then I'll just sweep the tool along the chamfer to remove any possible burr. So a combination of selecting geometry or inputting your own vectors in PartMaker is quite easy to do this. As a matter of fact, on simple jobs, people won't even draw the geometry. If they're creating a pin with chamfers and maybe a cross hole, they'll just go into the tool path itself and use the ZX vectors to type in for the start point for the tool path, the X values, Z values, and build the tool path without any geometry on the screen. Okay, so using the strategies, next we set the groove strategy. So I'm going to groove out the part. And again, you've got total control over the grooving strategy here. I'm just doing a very simple groove strategy to make room for the thread mill that's going on the edge here. Then I'll do the second turn. Rough out is, I'm just drilling through the center here to rough out some material. Then I'll do an ID bore to clean out the area that I can clean out with a turn cycle and cut off. Now again, this is not the order of operations. This is merely the features required to make the part. So when I am in a specific construction plane, I'm going to do all the work that needs to be done in that plane. So I'm going to face it, turn it, groove it, do everything I can do in the turning window, including the cutoff. Once that's done, then what I need to do next is determine how I want to work on the rest of the part. In this case, we're going to work on the face here. So that's going back into the setup dialog box, telling the system you're working with a new main spindle window. And the window that we're choosing is the mill end polar window, which orients the tool in Z, uses X for location and C axis for motion. So in this window, I did the face cutouts here first. Then we did the square pocket through. And let me slow this down just a tad so we can see that easier. Okay, and I'm using just Z-level stepping to clean out that pocket. Then the arc. And again, I could step this through or step it back. If I need to see exactly what's going on, I've got full control over the tool path in the 3D window. The outside contour. and then a thread mill. Now I decided to do a thread mill instead of a single point threading cycle, just to show you that PartMaker can handle just about any machining feature that you need to make. So when we do a thread mill here, I'm doing an external thread mill. We can do internal thread mills, external thread mills. We can also create a whole cycle for thread milling where we would spot and drill and thread mill. Now the whole group is only for internal thread mills, but if I had to do an external thread mill, I just do it through a profile group. Build the tool, determine the depth of the thread mill, put in the pitch for the thread mill, and run it. Okay. If we wanted to, we could tell the system, instead of going top down, let's go bottom up. And then the system will set itself to thread mill up the part instead of down the part. So you have your choices when it comes to thread milling. Okay, so that takes care of the face and the milling work on the face. Next, we've got some work around the side of the part that we need to do. That's going to be a mill ZY plane. The tool is oriented in X. We're using the Z and the Y plane for the motion of the tool. So again, into the setup dialog box, select the main spindle window. I'm going to make it a mill ZY plane, and I'm going to index it to 90 degrees. The mill ZY plane gives you the ability to index to a specific plane. So if you had features that needed to be timed together, we can time features together very easily just by indexing to the next angle in the C-axis we need to time those features together. Another thing that we can do is, once we've got the mill ZY plane set up, in this case, what we're going to do is we're going to create the through pocket here and then the U-shaped flat. Okay, so here's the cut for the U-shaped flat. And I'm just roughing out with the larger tool, cleaning up with a smaller tool so I can match my radiuses. Inside the profile group, as you can see, you just set up a contour pattern. Tell the system where you're comping the tool, left or right for climb or conventional cut. I can examine the model itself. So for instance, I'm just going to go ahead and extract parameters, select this surface to find out where the tool should be going to, extract that data, and it automatically fills in the values I need to put the tool into the correct position. Okay, we have total control over lead in, lead out. I'm doing a rougher with a 250, finishing with a 125, and I'm leaving 10 thousandths stock between the rough and the finish pass for cleanup. And another nice feature about PartMaker is you're looking at a single page to set up your tool paths. We don't have to go through tabs. We don't have to pick a tab for the tool, pick a tab for the strategy, pick a tab for the depths, pick a tab for the lead in, lead outs. It's all done on a single page, which makes it a lot easier to program that way. Now, there's a feature exactly the same on the other side. So I can go ahead and tell the system, if I've got the same feature on the other side, the mill ZY plane allows me to take that operation and duplicate it around the part. So if I had 3 features that were 120 degrees apart, I would just say, give me 2 other features at 120. I've got 1 feature exactly opposite to the ones I just created. So I'm just going to have the number of copies at 1 and the angle at 180. And that takes care of building both of these features at the same time through one construction plane. From there, we need to start working on the sub spindle. So back to the setup dialog box. In this case, you're going to click new and then tell the system you're working on the sub spindle. That's all you need to do. This is going to be a turning window. So when I create that window, view normal to the face plane, we will automatically flip the part around so that your programming technique is the exact same as far as tool paths go. You don't have to worry about working from one side to the other. You're going to start on the face, work your way left, just like we did on the main spindle. Your tooling orientation is going to be the exact same. You don't have to think about flipping tools around. All that's taken care of in the software. So we're just going to face the part. And again, subfacing was such a simple operation, I didn't even translate my geometry into the 2D window, but I could if I wanted to. I can extract my turn geometry and tell the system, give me a 2D profile, and check my facing operation there. So that takes care of facing it. Next, there's a lot of milling work to be done on the sub end. So I'm going to switch over to another construction plane. This time, the mill ZY plane is on the sub spindle. View normal to the face plane. And I really don't need that plane, do I? I can engrave it and mill 5 axis. Yeah, here we go. The sub end polar plane. What I'm doing here is I'm using a polar plane, but it's on the sub side. And I'm going to cut the flats here. And the reason I separated this instead of doing everything at once, there is a difference in Z levels between these two surfaces here. Okay, it's very subtle, but it's there. So we have to make sure that we create that feature. So we're just going to go ahead and mill the sides first. Then I'll do the center cutout and cut the center out. And again, I can do Z level stepping. I've got total control over the toolpath. And do the same for the other side. And then because we've got radiuses up here, I could have run a tool just around this edge here, but we also have these fillets on the corner here. So I decided the easiest way to do that would be to create a 3D surfacing strategy. And I'm just using a raster finishing technique here. I've got a 125 ball mill, and I'm going to set up a surface algorithm that'll allow me to surface all this on both sides of the part. And it's just going to go ahead and surface. Okay, so that takes care of our surfacing. Now, I actually created the sub mill ZY plane here, but since we're not using it, I could just right click and delete that face to get rid of it. So you can experiment with your toolpath. And then once you've got what you like, you can generate the process table and run from there. Now, we do have a little wrinkle on this part here. We've got these two 2mm holes at an angle. So what we need to do is we need to create a 5-axis plane so that we can get our tool perpendicular to the angle of the hole here. And in PartMaker, setting up 5-axis plane is very simple. In fact, I'll just quickly do another one for you so you can see that. So I'm going to go to Setup Dialog Box. There's the original 5-axis plane. I'd create a new 5-axis plane and just apply and close. Okay, what I'm doing here is I'm just setting up the plane. Next, I need to know what the coordinates for that angle is, the C-axis, the B-axis, and the local coordinates in X, Y, and Z. So instead of having to trig all this out from a drawing, I simply select the cylinder, go to define the face plane, and tell the system, in this case, create a surface plane or a construction plane that's normal to the cylinder, the top of the cylinder. But if I needed to, for whatever reason, I could tell the system, well, let's put it on the bottom side, and it'll shift it down, and you'll be approaching it from this angle here. We want it from the top side. So there's my plane, there's my angle. And that's as easy as it gets setting 5-axis plane. I can go back into my window and go to my face options, and it will calculate my 5-axis planes and my local coordinates for me and set me up so that I can just quickly and easily create a drill cycle for the 2mm holes. So again, we're just going to take this surface here, project it as arcs. There's the surface and the holes. And then I created a drilling strategy for the 2mm holes using a end mill at first, just to kind of take the angle off of the wall there and create flats. So we can step it through and then peck cycle to finish it off. So that takes care of the programming. Next, what we want to do is we want to be able to take all these features, look at the order of operations, reorder the operations, synchronize everything together, run simulation to make sure it's working correctly, and then post code. So we're going to generate the process table. And I'm going to start from scratch here, just so you can see how it's done. And then I'll call back in the finished part so I don't bore you to tears, resetting all everything on the process table. So again, here's your time chart down here. As you can see right now, we're not synchronized. The main spindle runs and the sub spindle runs separately, and then we go back to the main for some work. What's happening here is that after creating a sub spindle operation, I realized that I needed to go back to the main spindle so I can engrave the side of the part and I can do my 5-axis milling on the main spindle. So right now we're in main spindle work, sub spindle work, main spindle work. Well, we know that won't work on a machine. I can simply take the main spindle operations and move them above my subface. So now I've got main spindle work and sub spindle work. And let's put that one right there. There we go. On the left side of the screen, as you can see, are the tools that I'm using. So whenever I want to, I could just go ahead and edit the tool with inside the process table. We don't need to go back to the original tool path. The editing capabilities in the software are really functional. If I need to update, for instance, I go to my crib and I don't have an 8 nose radius, but I do have a 16 or a 4 that I can use. I can just jump into here and change the nose radius, and that will automatically update the tool path to the new nose radius. Part Maker will compensate all your nose radiuses and all your diameter values, so you don't have to worry about dealing with your offset page if you don't want to. Okay. The tool paths that you've created themselves can be edited within the process table. If your machine has got multi-coolant function, we will write those multi-coolant functions into the post. When you load the post, you'll see the multi-coolant button here, and you can change your strategy for your coolant calls if you have multi-coolant functions. You can update your feeds and speeds and lock them in place. You're seeing a bunch of padlocks here. If I wanted to, I could unlock it and work with constant surface speed, or just work with RPM and units per rev. On the right side, if I needed to, I could output a CAN cycle for turning. And in Part Maker, we've got 2 variations for that. CAN cycles for turning programmed means that the system is comping your tools. Compensated means that you will comp the tools at the machine. So for CAN cycle turning, we have 2 programming styles. Nose radius compensation, right now I'm letting Part Maker apply the comp. That should get me into the ballpark. Swiss machines are very accurate, so the software is as well. But if I needed to do wear compensation, or I wanted to sneak up on a really tight tolerance, I can always activate comp for the offset page, for your wear comp page on the machine. So if you had to comp the tool by a 0.5 thousandths, you could do that quite quickly and easily. If this is set to none, you will not see a G41, G42 in your code. We will comp the tool for you to get the diameters correct. If you wanted to see the G41, so you could work with the offset page, you could just switch over to what comp you want to use, and that'll output the code correctly for you. At the bottom of the page, we've got what we call user data switches. And what these do is these add functionality to the process. So for instance, if I'm threading and I'm using a G76 cycle, and I wanted to swap that over to either a G32 or a G92 cycle, I would go to the thread cycle, unchecked the CAN response, And if I wanted a G92 thread, I would just click this button here and would change the code out from a G76 cycle to a G92 cycle. So, you know, we have C-axis clamping, no tool offset, pause at the bottom of a tool path. All these features here, like non-polar incremental H, in case you need to use incremental polar or non-polar with incremental motion. These features are machine capable features. So if I need to use any of these, I just turn them on and I get the code flavored the way I want. So at this point here, I'm going to face it. And even before I do the turning, I want to start doing the ID work. So I'm going to grab the rough out, the ID bore, and put it under the main face. What else can we do before we need to turn the part? We can do the face cutouts, the square pocket, and the arc with chambers. So as you can see, I can grab multiple profiles and place them where I want to reorder the operations so I get a more efficient strategy. Then after the first turn, I can groove it. And after grooving it, we can put in the external thread. We can put in the thread whirling, do the outside contouring, then work on the side of the part. So once we have our order of operations set, on the right side of the page is where we do our synchronizing. The first thing I like to do, by the way, is to set my cutoff process, because that's probably the one I forget the most. What I'm going to do for the cutoff process, I'm going to go to the mode button, and you're looking at our visual synchronization here. You read what you want to do. In this case, I want to machine with one tool on the main, which will be the cutoff blade itself. And while I'm doing that, I want the subspindle to be supporting the part. So on the subspindle side, I'm going to go to follow support, and then I'm going to put in a grip length for that support, wherever that value is that I want to grip the part with. Select OK. The mode button updates M1SF, which means main spindle 1 tool, subspindle support function, and we're now supported. We could run the main spindle and the subspindle separately, but if I wanted to save time on the machine, I'm definitely going to want to take my main spindle and my subspindle and synchronize it. So starting on the main face here, I'm going to select my mode button for the main spindle. And while I'm working with one tool on the main, I want the subspindle to be working with one tool on the sub. And again, in PartMaker, you just read through the list. Follow support, nope, there it is. Machine with one tool on the sub, it's going to match them together. Since I want all the other main spindle operations to do the same thing, I'll modify all the modes at the same time, select OK, and you can see that we're now prepped for synchronization. Now, the subspindle doesn't automatically get updated, because if we did that, you'd only ever get one sync state. So we can synchronize in multiple operations. We may want to do some main and sub work and then pause the synchronization because I'm going to use the subspindle to do gun drilling, something like that. And then once that sub is stopped being used for the tool path, we can resynchronize. So we can make multiple sync states. And that's why you synchronize your main and your sub separately, so you have the opportunity to do that. In this case, I need to be machining with one tool on the main while the subspindle's working. So there I am machining with one tool on the sub. I'm now going to place one tool on the main for all the sub operations. And I prep my sync group here, and I can synchronize. And that's it. You're done. You're done synchronizing. We don't need any third-party software. No PC Junior, no Wincom CNC. Everything will be done within the software here. So I'm just going to recall my job file here. And the reason I'm doing that is because I had a specific sync operation, and I just don't want to bore you to tears by resyncing everything together. Okay, so here's our process table with the processes reordered, the feeds and speeds set and locked, and on the right side, the synchronized part. At the bottom here is our time study, and we got a large time study here because I'm doing surfacing, and surfacing usually takes a little bit longer. So from here, we can go to simulation, And I'm showing the full machine simulation right here, but we can also show the basic simulation. And this is the one that I use most often because it's the simplest view. Let's set up our part. We don't need to worry about that. We don't want to hide the tool holders. And we can run our simulation. I can speed it up or slow it down if I need to. I can reorient it to see what's going on with the tools. I can pause it, speed it up, slow it down. Thread whirling, or thread milling, excuse me. 5-axis, engraving. And then when I pass it off to the sub side, you'll see the tools working together. Okay, so that's our basic simulation. And a lot of our post processors will have a machine kit with them. If the machine tool maker is willing to share their files with us, we can create FMS kits. If they don't share their files with us, we can't create the kits. We've been pretty lucky so far. So this is actually what we're looking at here is a Star SR20R4 Type A with B-axis capability. And that's why I'm using this machine, so I can get those holes drilled in the side there. Okay. So here's our full machine sim running. There was the 5-axis plane right there. And the engraving. Okay, and then the machine working together on main and sub at the same time. So I'm not going to bore you to tears here. I'm just going to show you the finished part. Well, we're generating the finished part. Does anybody have any questions? No. Okay, some of you guys don't have microphones, but Jacob or Robert, you should be able to communicate with me now. Do you guys have any questions?
Not really. I don't know, maybe Jacob does.
Okay.
Thank you.
You're welcome. So here's our finished part. Looks good. Everything's where the features are supposed to be. I like the result. So at this point, I can generate my process table code, and I can do that in two ways. The first method is to create quick NC program view. And what this does is this just pops the code up on the screen so I can look at the code before I decide to generate a file for the machine. When I do that, I'm going to get my post options dialog box open up. And here I can set a program number if I need to. If I've got a bar loader that's using a macro, I can put in the macro number for the bar load. I believe the coordinates are local for the 5-axis plane on this machine, but we'll find out in a minute. The weight queue commands, where am I starting my weight commands and what's my increment? Air blast is a generic term for flushing the sub spindle before pickoff. Most modern machines do have cutoff detection. In the middle of the page here, this phase angle, notice I have a 0 in here. I always tell my students just to place a 0 in there and then leave it alone. What this does is this prompts the post processor to make sure that your C-axis angles are equal between the main and the sub spindle for pickoff. Now on round stock, it's not really necessary, but if you're going to be working with hex stock or square stock, or you've got a sub spindle collet that's been wired to a specific shape for pickoff, we need to make sure those C-axis angles are equal. And by putting a 0 in here, you'll get the M call for the C-axis sinking. Again, is it necessary for round stock? Not really. But if you put it in there and leave it alone, you won't have to worry about it when you need it. Okay. The right side of the page, you could put in maximum and minimum spindle speeds if you want to. And we have a feature called Stop to Include User Input. A lot of our post processors will prompt the programmer with specific questions, and then once he answers those questions, it will flavor the code. So I definitely want to see what those prompts are before getting the code. So I'm going to leave this turned on. Select OK, and there's my prompt. Am I using a JBS bushing? Well, today I'm not, so I'm going to set to no, and it's going to generate my code. Main spindle, sub spindle, head 1, head 2, $1, $2 if you guys are running citizens. But we can also do certain things like aligning to make sure that our sync states are correct. And this is a single sync state, so we're not going to see a lot of aligning because we're running main and sub basically at the same time for all tools. And then what you'll get is your cutoff process, and this is where we're going to see a lot of the synchronizing and the lining up. Okay. Any questions on that? And finally, generate an NC program. Name the program, save the file. You'll get your splash panel popping up, letting you know that you generated your files for the machine. And I can view the NC program or launch an NC program editor. In this case, it's just Notepad. But if you have your own editor that you like to use, you can go into your preferences and select an editor. Like if you had Simco or Predator Editor or NC Simulate. If you don't have that, we have a multi-channel editor. And what that'll do is when I generate the NC program and I launch the NC program editor, it's going to launch our multi-channel editor. And show head 1, head 2. If you have a 3-channel machine, it'll show the 3 channels. Whatever number of channels you have will display for you. So that's basically soup to nuts for part maker. And again, if you're looking to simplify your Swiss programming, this product will definitely do it for you. Especially if you're having to get into more advanced features like undercuts, surface machining, 5-axis positioning, 5-axis simultaneous. You want to experiment with tool paths. There's a lot of different things you can do with this software that will help you speed up your programming. So at this point, we're pretty much done with the presentation. Does anybody have any questions or concerns? Let me know.
Well, now I got a question.
Yeah.
When you were talking about the B-axis, whether you had to select global or local coordinates.
Yep.
I remember when we do that, we had to experiment.
Yeah. So normally what you can do is you can call up your machine tool dealer and you can ask him how you set your 5-axis coordinates. And he'll tell you it's either a global coordinate from a pivot position or it's a local coordinate because you're using tool tip compensate, TCPC. I think it's what it is. Basically, you're creating a local coordinate. You're creating a plane with BC, XYZ, local to where the part is. In most of our posts, if we set this incorrectly, if I go to global coordinates here and run code, in many cases, it'll tell me that, let's see, let's go down to where those 5-axis planes are. Red mill, contour. Polar coordinate. second turn. It's calling your G910. In fact, this post processor is automatically set to local coordinates based on what Star wants to see.
Okay.
So your G910 is a call for a local coordinate, X, Y, Z, B, and C. Okay?
Thank you. Thank you, Phil.
You're welcome, definitely. Anybody else have any questions?
Hey, Phil, I do have just a couple of slides, and we are running towards the end of the hour. If you want to swap back.
Yeah, go ahead. I'll stop sharing. And go ahead. You got it, Eric.
All right. So fantastic job, just Phil, going over it. I always love to watch the machine and everything coming together on these parts. It's fun to watch. Here's a success story we have from a company called North Star CNC. And this is not untypical from folks, especially if you're coming from manual programming or you're using a CAM software that doesn't do Swiss programming particularly well, or just doesn't have the post processors or the capacity. This customer is really good. They were originally moving from hand programming, and they wanted to move to offline programming. We put Autodesk PartMaker into play with them, put together services, and you can see the result here that they had about a 90% reduced programming time. Also, a lot of different areas of the business that came through. So this is not untypical from what a lot of folks are able to achieve. You definitely have to have good programmers that know the machines well, and then matching the software into that process is great. One thing people aren't usually aware of is that PartMaker comes in a bundle, and it comes with 4 total products from Autodesk. And it's not an increased price because of those products either. So you're getting those at no additional cost. So you're getting FeatureCAM, which is the industry's top feature-based programming tool. It's great for milling and turning, complex turn mill also. And it can do a lot of things automatically by recognizing features and doing the programming. It's a very beloved program that a lot of shops are using and depend on that to get all of their jobs done on time. PartMaker we just went over completely today. Fusion 360 is one of the most popular CAM systems out on the market. Most new programmers that are getting into the market are buying this as a majority of the new seats being sold in the market. And then there's also a machining extension, which is an additional charge typically that comes in here to allow you to do 5-axis milling and some automation on the Fusion platform. So if you take all of this together, you could really run any machine in your shop. You're pretty much on the path to getting increases in your productivity and the results that you're looking for. Another thing that comes up a lot is the on-machine verification inspection that comes with Fusion's another thing that folks are using on that side of the equation. If you look at Fusion overall, we just step back a bit from just CAM itself, Fusion is also a platform that puts everything, especially for a small manufacturer, into one package, where it is the 3D design tool, it's engineering and quoting for your business, it's also the production engineering and CAM programming that you would do, and then getting out onto the shop floor and doing things there. There's a whole host of products that come with Fusion, and additional, there's quite a few extensions and different products for a variety of different things that can be done with that tool. So this has been Swiss Made Easy, and we went over the value of having a purpose-built tool to make it easier to program really complex parts and complex machines, reducing cycle times. And then I just want to encourage you to engage with us, engage with our technical team. We do a lot of training. We have 3 different courses that are standard for PartMaker. We have an essentials course, we have a turn mill course, and then we have an advanced course for training. On the Fusion side, we also have a whole set of classes which we call accelerators to train you in just about any area of Fusion, and you could look into those. Definitely work with us on the service side. We won this award that we're very happy to let folks know that we won Autodesk Top Service Partner for 2022. We won that award back in March, and it's great to be recognized. It's even better if we can connect our team to help your programmers and your people solve problems. We are a gold partner with Autodesk with a variety of specializations here, and we are just right at the top of the hour. I want to thank everyone for joining us, and if you want to get a hold of us, you can get a hold of us at info@nextgencam.com. There are a variety of places. If you hit our website down here at the bottom, nextgencam.com. Thanks again, Phil, for a great presentation. And Joy, do you have anything to add as we close it out?
No, you covered it all.
All righty. Well, let's give everybody their Friday back and have a great weekend.
Yep. Thanks for your time, guys.